successfully delivering value, interpreting the world's best books. Hello, this is Sally's Book Talk. Today I'm interpreting the book A Short History of the Human Body. In the first chapter, the author poses a mind-blowing question. How much does it cost to make a person? Historically, scientists have actually explored this question. At the 21st Cambridge Science Festival, the Royal Society of Chemistry calculated the value of the 59 chemical elements that make up the human body. They concluded that the material cost to make a person is about 96,546 pence, 0.79, roughly equivalent to 850,000 Chinese yuan. However, chemically speaking, the elements in your body can all be found in dirt, but when they form your body, it's the miracle of life. No matter how much money you spend or how carefully you assemble them, you can't make a person out of these elements. The human body is so miraculous, and we've always taken for granted living in this warm body. However, have you ever wondered why you are the way you are? What unsolved mysteries does the human body hold? The answers are all in the book we're discussing today. The author of this book is Bill Bryson, an American writer known for his popular science masterpiece, A Short History of Nearly Everything. He's an honorary fellow of the Royal Society, has worked for the Times and the Independent, and was appointed Chancellor of Durham University. In recognition of his outstanding contributions to literature, in 2006, Queen Elizabeth II awarded him the Officer of the Order of the British Empire, OBE. Other recipients of this honor include J.K. Rowling, author of Harry Potter, and martial arts masters. To write A Short History of the Human Body, Bryson spent 17 years personally visiting 18 internationally leading academic and medical institutions like the Newton Institute and Harvard University. He conducted in-depth interviews with 38 top scholars and doctors in the medical field, gathering vast amounts of data. Hard work pays off. Upon publication, the book received widespread acclaim from professionals and the public and has been translated into over 20 languages for global release. And so, the book has 23 chapters, each with a relatively independent theme, covering various aspects of the body, such as skin, head, pain, pregnancy, and cancer. But next, I've reorganized the book's key points, summarized into three main questions. First, compared to other animals, what makes humans unique? Secondly, what efforts has the body made to survive? Thirdly, how to stay away from diseases and maintain health. First, let's talk about the first question. What makes humans unique compared to other animals? The author lists many unique human features in the book, and the most important can be summarized into 4 points. A strong brain, standing upright, sweating, and eating cooked food. Now, let's go into specifics. When it comes to differences between humans and animals, you might first think that humans are smarter than animals. This is thanks to the human super strong brain. Compared to other animals, the human brain has a larger proportion relative to body weight. An adult human brain weighs about a kilogram or more, roughly 2% of the body weight. In comparison, the brain of our close relative, the gorilla, makes up only 0.2% of its body weight, while a sperm whale weighing 40 tons has a brain that's only 0.02% of its body weight. Thus, it's clear that human brain size is much larger than that of average animals. Besides that, the structure of the human brain is more complex than animals, especially with its unique neocortex. This is the foundation of human higher consciousness and the key feature distinguishing the human brain from other animals. Ah, But strangely enough, chemically speaking, the elements that make up the brain, like carbon, hydrogen, oxygen, nitrogen, etc., the human brain isn't much different from other animals' brains in terms of composition, and about 80% of it is water. So next time someone says your brain has water in it, don't rush to get upset. They might just be describing an objective phenomenon. The rest is mainly fat and protein. However, these three ordinary substances combined have actually created the whole world for you. The brain sits quietly in your skull. It has no eyes, nose, or ears, and no senses. For the brain, everything in the world is just electrical pulses transmitted through nerves. That is, various external stimuli cause biological currents in the body's receptors. This extremely tiny current is transmitted to the brain in a pulse-like rhythm. Through this Morse code-like information, the brain creates a three-dimensional, vibrant, and fascinating world for you.
Everything you see, hear, or feel is told to you by your brain.
In this sense, your brain is the entirety of your consciousness. All other organs are merely supportive scaffolds and pipelines for the brain. For example, take what we see. Light enters your eyes, generating electrical signals. These signals are transmitted to the brain via the optic nerve, but they're only a small part of seeing. When you see something, only 10% of the information comes from the optic nerve. The rest is calculated and analyzed by the brain. Now, what is the brain tells you that the received information is blue sky and green grass, and it also helps you judge what's approaching, whether it's a speeding car or your boss. So it can instruct you whether to dodge quickly or smile and approach. In other words, the most important part of seeing isn't receiving image information, but understanding it. You might have done an experiment where after staring at a red paper for half a minute, you immediately shift your gaze to a white wall and you see a ghostly blue-green square on the wall. This blue-green color obviously doesn't exist. It's the result of brain fatigue and only exists in your imagination. When your brain can't adjust in time, you see colors that don't exist. In fact, not just when fatigued, all colors you see normally are like this. Contrary to common belief, photons have no color. Sound waves don't make sound themselves, and odor molecules have no smell. This colorful world isn't the true nature of things. Everything is created by the brain. The brain processes information with super strong analytical abilities, far surpassing computers. In 30 seconds, it processes more information than the Hubble Space Telescope in 30 years. And a 1 cubic millimeter piece of brain cortex can store 2,000 terabytes of information. What does that mean? 1 terabyte equals 1,244 gigabytes, and a 720p movie is about 4 gigabytes, meaning a 1 cubic millimeter brain cortex can store approximately 400,000 movies. Besides a strong brain, humans also stand upright, meaning bipedal walking, which is another defining characteristic that distinguishes us from other animals. Among about 250 species of primates in the world, only humans choose to stand up and walk steadily on 2 legs. Other apes and monkeys can only stand occasionally, mostly crawling on all 4s. To walk upright, human body structure underwent significant changes, such as in bone shape. Our necks became longer and straighter to support the head when upright. Human leg bones are also significantly different from those of other animals. You might think your legs are vertical, but actually human thigh bones angle inward. This clever angle brings the lower legs closer, making walking more stable and faster. Straight leg bones, on the other hand, are characteristic of apes. This bone structure means that even with training, they can't walk as gracefully as humans. However, the process of evolution must have been painful. Our ancestors not only endured the pains of structural changes, but also likely suffered accidents during evolution. According to scientific research, Lucy, the earliest known hominid fossil, died from a vertical deceleration event. In other words, Lucy probably didn't stand steady on her 2 legs and fell from a height. She fell to her death. But after overcoming these difficulties, our ancestors found that walking upright did bring significant advantages. For instance, standing upright makes humans appear larger and more intimidating than 4-legged animals, while also providing a better view. After humans stood upright, their hands were freed to use tools. They also evolved flexible shoulder joints, highly rotatable waists, and strong arms. These parts work together, enabling humans to throw stones at speeds up to 150 kilometers per hour, aiding in hunting. Additionally, human necks evolved strong ligaments to keep the head stable during movement, so we don't get jolted dizzy while running. All of this gave our ancestors an edge in fighting various beasts, ultimately becoming masters of nature. We know humans aren't the strongest or fastest runners in nature, but we do have excellent endurance during exercise. Well, this is thanks to another key human trait: sweating. Sweat glands are widely distributed across human skin, regulating body temperature through perspiration, which is crucial for humans. Consider this: most mammals have very few sweat glands. Dogs only have them on tongues and paw pads, while chimpanzees, our closest relatives, have half as many as humans. Animals rely on panting to exhale warm carbon dioxide and water vapor for cooling. If they can't stop in time to catch their breath and cool down after intense exercise, they'll overheat quickly and lose mobility. Most animals collapse after running about 15 kilometers nonstop. In extreme cases like cheetahs, they can't run for more than a minute. However, humans can sweat to cool down and run for long periods. So this gives an edge in struggles with animals, but frequent sweating makes body odor less pleasant. But actually, sweat itself has no smell, no matter where it's secreted from. You think sweat from armpits and feet stinks because those areas have lots of propionibacterium and brevibacterium. These bacteria break down chemicals in sweat to produce the odor. Funny thing is, we use the same bacteria when fermenting cheese, so fresh cheese has that familiar stinky feet smell. So humans evolved this way for better movement. Therefore, even today, when we don't need to hunt gazelles or bison, we still need exercise to avoid health issues like obesity, back strain, diabetes, and cardiovascular diseases. So, how much exercise should we do each day? Japanese scientists recommend walking 10,000 steps daily, while US CDC experts suggest about 150 minutes of moderate exercise, like brisk walking or jogging. Sadly, many people can't meet either standard, leading to illnesses. No doubt, improving health requires exercise since our bodies are built for it. Besides exercise, diet is also key. That brings us to the fourth unique feature of humans: eating cooked food. Around 300,000 years ago, perhaps by chance, human ancestors ate wildfire-cooked meat and loved it, so they learned to use fire for cooking and refined the techniques. B. Compared to eating raw food, cooked food has many benefits. It kills most bacteria for healthier consumption and improves taste, making inedible foods delicious, expanding the range of human food choices. But most importantly, cooked food dramatically increases the calories humans extract from what they eat. In nature, whether eating raw meat or plants, energy extraction efficiency is very low, so animals easily get hungry.
To meet survival calorie needs, animals spend most of their day eating.
For example, primates spend 7 hours chewing food daily, while cows, horses, and elephants spend almost all day repeatedly eating and digesting. But with cooking, humans escaped this animal fate. When food is cooked, macromolecules like starch and protein denature, becoming easier to digest and absorb. Take potatoes. Cooked potatoes have 20 times higher digestibility than raw ones. Thus, cooked food provided abundant calories, freeing humans for other activities. Finally, after millions of years, humans evolved to walk upright, freeing hands, developed sweat glands for endurance running, habitually ate delicious cooked food without constant foraging, combined with a powerful brain granting supreme wisdom, making humans unique beings, the rulers of this world. Yet even so, humans aren't invincible or always successful. Throughout life, humans face threats like disease and aging. So how does the body resist these threats? The author lists many defense mechanisms. I'll focus on 3 key points. First is the nervous system self-protection, with sleep being crucial. Lack of sleep affects health and can be fatal. In 1989, University of Chicago conducted a cruel experiment, placing 10 rats on water, surrounded rotating discs, continuously monitoring brainwaves with computer sleep detection. When rats dozed, The disc rotated suddenly, keeping them awake. After about 10 days, all rats died. Autopsies showed no disease. Their bodies simply gave up. You might think sleep is rest, but your body isn't slacking off. During sleep, your body checks and adjusts itself, consolidating memories, restoring hormonal balance, clearing neural toxins, resetting the immune system, and more. Sleep isn't just closing and opening your eyes. Research confirms normal sleep has cycles. The initial stage is sleep onset, where you gradually lose consciousness and enter sleep. For about 20 minutes next, we sleep lightly and nourishingly, similar to napping. In these two shallow stages, you might even think you're awake.
Next comes non-REM sleep stage classification, sometimes divided into deep sleep and slow wave sleep stages.
This stage lasts about 60 minutes. We sleep deeply, and waking is very difficult. The final stage is rapid eye movement sleep. In this stage, though asleep, eyes dart rapidly under eyelids, as if watching an intense movie. REM duration varies, totaling about 2 hours per night, roughly a quarter of total sleep. During this phase, certain brain areas are highly active, and most dreaming occurs. When startled from a sweet dream, you might wonder, why can't dreams start earlier? The reason lies here. When you dream, sleep is already in its final stage. Though asleep, your brain isn't fully resting. Heart and lungs still work diligently, but muscles controlling movement are paralyzed. It's fresh water to wide water unfurls. This paralysis is actually protective, preventing you from acting out dreams and harming yourself or others. Normally, it lifts upon waking. However, if awakened abruptly by nightmares or noise, this paralysis might not disappear immediately. Thus, you find yourself awake but unable to move. Combined with midnight surroundings or recent scary dreams, this feels terrifying, leading to the folk term ghost pressing on bed. Fortunately, this lasts only minutes at most and causes no harm. Besides sleep paralysis, you might have experienced sudden falling sensations while sleeping, actually just a leg jerk called hypnic jerk, or myoclonic twitch. Why do we have this feeling? This traces back to our ancestors when they slept in trees. Back then, humans had to be careful not to fall from trees. The hypnic jerk is like a fire drill. When we sleep, some part of our body is still watching the outside world, protecting us. So, no matter how deeply or restlessly you sleep, you rarely roll off the bed, even on an unfamiliar bed. The second way the human body defends against health threats is through the immune system. In the entire immune system, the first line of defense is our skin. As the body's largest organ, it wraps around other internal organs like the Great Wall, blocking most pathogens outside. It also regularly sends out advance troops like tears, mucus, earwax, and sebum to clear enemies on the skin surface, such as dust, dirt, and bacteria. When invaders breach these external defenses, they quickly face the immune system's regular army. Swarms of immune cells march out from lymph nodes, spleen, bone marrow, thymus, and other body parts, fearlessly charging at the enemy. During this process, blood vessels near the battle site expand, allowing more blood to flow there. The blood flow acts like a transport team, bringing more nutrients and reinforcements. This causes the area's temperature to rise. Tissue swells, increasing pressure on surrounding nerves, making the area sensitive and tender. That's when you realize inflammation has occurred. For example, the tonsils, located in the throat where they're most exposed to foreign germs. When encountering bacteria, the tonsils immediately call for reinforcements via the blood, causing themselves to swell and enlarge. They also secrete large numbers of lymphocytes to fight the bacteria. Finally, these sacrificed lymphocytes and pathogens mix together, forming visible, sticky secretions. And your sore throat is also due to this swollen tissue. It's through signals from the nervous system. Essentially, inflammation is the body's protective measure to shield itself from harm. Immune cells use a chemical called cytokines, which can kill invaders, but also make you feverish and weak. The pus that oozes from wounds is composed of cells that sacrifice their lives to protect you. Inflammation is tricky. If it's too weak, it can't stop infections. But if it's excessive, it damages nearby tissues, causing issues like ulceration. In some people, even harmless invaders can trigger an overreaction from the immune system. This is what we usually call an allergy. Nearly 50% of people worldwide are allergic to some substance. Allergens range from antibiotics, crayfish, pollen, alcohol, to latex pillows, with an enormous variety. Statistical studies show that allergy rates are closely tied to economic conditions. The wealthier a country is, the more likely its citizens are to have allergies, though the exact reasons are unclear. And it might be because people in wealthy countries are exposed to more pollutants, or they lack exercise and have higher obesity rates, indirectly affecting their immune systems. Most allergies only cause minor discomfort, like redness and swelling, but some can be life-threatening. For most people, if they know their allergens and avoid them, there's no need to worry excessively. However, those with autoimmune diseases aren't so fortunate. What is an autoimmune disease, such as systemic lupus erythematosus, rheumatoid arthritis, Hashimoto's thyroiditis, and so on? The allergen for these diseases is the patient's own body organs.
Their immune systems treat their own bodies as enemies, attacking relentlessly, which remains a medical challenge today.
Scientists find it hard to pinpoint what's wrong with these patients' immune systems, that they fiercely attack even their own bodies. Moreover, autoimmune diseases show severe gender bias. For example, women are 10 times more likely to develop systemic lupus erythematosus than men, and 50 times more likely for Hashimoto's thyroiditis. Scientists speculate that estrogen might be the culprit. The third way humans defend against health threats is by controlling aging. Modern humans live longer than ever, and people often say living to 70 was rare in ancient times. But now, the chance of a 70-year-old dying within the next year is only about 2%. However, with longer life expectancy, various illnesses follow. For instance, as the incidence of diseases like diabetes, coronary heart disease, and Alzheimer's rises among the elderly, various cancers also seem increasingly common. Many people blame the high cancer rate on modern environmental pollution, thinking ancient people rarely got these diseases. But archaeological findings show ancient people did get cancer. They just had shorter lifespans. Many died from minor illnesses or accidents before they could develop cancer. Scientists calculate that even if we cured all cancers tomorrow, human life expectancy would only increase by 3.2 years. Eliminating all cardiovascular diseases would only add 5.5 years. That's because most who die from these diseases are already elderly. Even without cancer or heart disease, aging would claim them. In other words, while medical technology fights diseases, nothing can resist aging itself.
Why do we age?
Scientists proposed theories: gene mutation theory, genes malfunction and kill you; wear and tear theory, the body wears out like old machinery; and waste accumulation theory, cells build up toxic byproducts over time, damaging the body. These weren't correct. In 1961, an American scientist named Hayflick found the answer. While culturing human stem cells, he discovered they only divide about 50 times, then mysteriously stop dividing and renewing, inevitably leading to tissue aging. Hayflick also found these cells, even after years frozen, resumed aging precisely from their pre-freeze stage upon thawing. This phenomenon, called the Hayflick limit, was a biological milestone, first recognition that aging is cell-controlled. Further research revealed telomeres, DNA segments at chromosome ends that shorten with each cell division until reaching a set length, triggering cell death. This is the secret of aging. If we could stop telomere shortening, humans might achieve eternal youth, though this remains a hopeful dream. Until then, we all inevitably march toward aging and death. Most people lose their appetite for food and drink in their final days. Some people also lose the ability to speak, and breathing becomes extremely labored as death approaches. Since people are so fearful of death, how can we live healthier lives? First, we must maintain an optimistic mindset. The renowned German philosopher Kant believed optimism is the hallmark of mental health, and emotional optimism promotes longevity. Scientists later confirmed that happiness activates all organs, accelerates blood circulation, and boosts immune function, reducing illness susceptibility. Additionally, optimistic people are more sociable and better at maintaining mental health. Guinness World Records certified the world's longest-lived woman. Jeanne Calment lived to 122, outliving her husband by half a century and her daughter by 63 years. Her secret was approaching each day with enthusiasm and maintaining optimism until her passing.
Secondly, we need a healthy lifestyle.
This includes balanced nutrition, moderate exercise, no smoking, limited alcohol, adequate sleep, and good hygiene. Though it sounds cliché, studies confirm nearly all long-lived individuals follow healthy lifestyles. Finally, guard against overtreatment. Modern people increasingly value health. Many undergo regular checkups to screen for diseases early and enable prompt treatment. This is positive, but with terrifying diseases like cancer, fear or subsequent treatments like chemotherapy or radiation often cause more harm. Meanwhile, the cancer itself may have done little yet. The author's warning against overtreatment means don't avoid doctors, but stay optimistic before real threats emerge. Don't lose hope or aggressively medicate prematurely. All right. Through a short history of the human body, we've rediscovered our bodies. You might wonder, why, after so much evolution, is the human body still imperfect? For example, the human pelvis is too small. Childbirth requires excruciating pain equivalent to level 12. Another example, humans need extensive exercise and dietary control to stay healthy. Otherwise, lifestyle diseases easily emerge. Don't forget, our bodies evolved for hunting and gathering lifestyles. Our ancestors couldn't predict life in the information age. The miracle of human life isn't that we're born imperfect, but that we aren't overwhelmed by these imperfections. While humans actively seek solutions to disease and aging, our bodies continue evolving silently. That concludes our interpretation of a short history of the human body. Reading notes are below the audio. See you next episode.